Now this question says, work out the size of an exterior angle of a regular pentagon. Okay, and then another one says that the diagram shows a regular hexagon and a square. Calculate the size of angle A. There are so many of them, so many questions on that, on polygons. So it's going to take us to a topic called polygons. First of all, what are polygons? Okay, a polygon is a two-dimensional closed shape with straight sides. Okay, it's a two-dimensional closed shape with straight sides. We have two types. We have regular polygons and we have irregular polygons. Okay, we have regular polygons, irregular polygons. Regular polygons are the ones that have all sides equal. Okay, all angles equal. Okay, they're the regular polygons. These ones now, they don't have all sides and all angles equal. Examples of polygons are square, or okay, let's start from 3 sides. Triangle, 4 sides, maybe square. 3 sides are the ones that have 3 sides are the triangles. The ones that have 4 sides are the quadrilaterals. Okay, an example is a square. Then you have 5 sides pentagon, 6 sides hexagon. This is 5 sides. 6 sides hexagon. 7 sides hexagon. 8 sides octagon, and so on. Okay, now we're going to start looking at properties of these polygons. That's the regular polygons. Okay, we first said that all sides of a regular polygon are equal and all angles are equal. Okay, now how do you name your polygons? How do you know the angles? That's the size of the angles, the sum of the angles inside the polygon, and things like that. Now this takes us to angle properties. Okay, now talking about angle properties, if you have a quadrilateral like this, now this is a square, but let's look at something more. Let's look at something more. So if we have a line like this, it's going to divide this quadrilateral into 2 triangles. Okay, now for a pentagon that has 5 sides, I have 1, 2, 3, 4, 5. Let's say this is a pentagon that has 5 sides. Now if you're able to divide this pentagon into triangles using full diagonals, meaning that it should go from one diagonal to the other end. This goes from another to the other end without the lines crossing. Okay, now this will show you that a pentagon can actually divide into 3 triangles. Okay, now pentagon has 5 sides. Remember, a quadrilateral has 4 sides, and you can divide it into 2 triangles. Okay, same way too, a hexagon that has 6 sides. Let's see, 1 2 3 4 5 6. Now from this hexagon, if you divide it using full diagonals, you find out that you can get 1 2 3 4 triangles from it. And hexagon has 6 sides. Okay, now you know that the total sum of angles in a triangle is equal to 180 degrees. Angles in a triangle is equal to 180 degrees. Okay, now for us to be able to calculate interior angles of a polygon, okay, we'll use this formula, n minus 2 times 180. Okay, that's calculating from the number of triangles that you can form from that polygon. For example, for a hexagon, you can form 4 triangles. Okay, when you just do 4 times 180, that's going to give you about 4 times 3, 4 times 8, 32, 2 carry 3, 4 times about 720 degrees. Okay, now let's use this formula. N meaning number of sides, 6 minus 2 times 180, which is 4 times 180. Okay, you see how we derived this formula for interior angles of a polygon. So whatever number of polygon, whatever type of polygon you're given and you're asked to calculate the formula for the interior angle, you just know that it's n minus 2 times 180. Okay, n minus 2 times 180, that's interior angles of a polygon. Okay, now if you're asked to calculate that's an angle, each angle, okay, now this is to find the total number of angles or the total angle inside the polygon. If you're asked to calculate each angle of the polygon, it's going to be n minus 2 times 180 divided by n, so that when you have 720 degrees as the total angle inside a hexagon, if you want to find each angle, you just divide by 6, which is going to give you 120. Yes, that's 1 2 0. Okay, 120 degrees. That each angle is 120 degrees. So this is the formula for calculating each angle of a polygon. Okay, now if you're asked to calculate the exterior angle of a polygon, okay, just bear in mind that total sum of exterior angles of a polygon equal to 360 degrees. For example, if you have something like this is a quadrilateral, and you have something like this, maybe you have something like this, maybe something like this, and something like this. If you calculate all these exterior angles, it's more like going round. Maybe from this point you went to this point, you went to this point, and you went to this point. Remember that angles at a point is 360 degrees. Okay, so if you're asked to calculate sum of exterior angles in a polygon is 360 degrees, then if you're asked to calculate each exterior angle, that's one exterior angle, you know that is 360 degrees divided by n being the number of sides. If it's 6 sides, you know it's 360 over 6. You know if it's 4 sides, you know it's 360 over 4, and things like that. So use this formula to calculate the angle, or each exterior angle of a polygon. Now another thing again that we need to understand is that interior angle of a polygon and the corresponding exterior angle add up to 180 degrees. Why? They are angles on a straight line. So this angle and this angle has to add up to 180 degrees. Okay. Now, having learned all that, let's go back to our question. That's for the first question. We are told to work out the exterior angle of a regular pentagon. Now, they've told us a pentagon, and we've seen that from here is 1, 2, 3, 4, 5. It's 5 sides. Polygon with 5 sides. Okay. Now, we are told to calculate an exterior angle, just one. You know that some of exterior angles is 360 degrees. So one exterior angle would be 360 over n, and then we're told that n is 5, which is 360 divided by 5, which is 72 degrees. So that's it for that one. Okay. Now for this one, we're told that the diagram shows a regular hexagon and a square, that we should calculate the size of the angle A. Okay, that's this A now. Okay, now looking at this now, we'll find out that this, you can actually extend a line this way. Now you're still going to use some of exterior angles and solve this, but it's going to be some of exterior angles of two ways. Now you notice that this place now is the exterior angle of this quadrilateral, that's a square, and this part now is the exterior angle of this hexagon. Okay, now let's find out exterior angle, one exterior angle of a hexagon is going to be 360 divided by 6, that's 60 degrees. Okay, so also find one exterior angle of a square is going to be 360 divided by 4, and that is 90 degrees. So therefore A equal to 60 plus 90, which is 150 degrees. Remember, A is exterior angle of a square and exterior angle of a hexagon. Okay, so it's just exterior angle that we use in solving this. Now we got our answer as 150 degrees. Now this one also says that given this, okay, we're now told to find out the value of x. Okay, now again we'll ask ourselves, what shape is this? This is a quadrilateral. Now this being a quadrilateral, it means that it has 4 sides. Okay, so the interior angle is going to be 180 into n minus 2, which is 180 times 4 minus 2, that's 2. Okay, 4 minus 2. Let's write everything fully. 180 times 2, which is 360 degrees. So all these are supposed to sum up to 360 degrees. Okay, now trying to do that, we'll have 3x minus 15 plus 2x plus 2x plus 24, then plus 2x, 360 degrees. Okay, so now we have to gather like terms. 3x plus 2x is 5x, plus 2x is 7x, plus 2x is 9x. So we have 9x. 24 minus 15 is plus 9, equal to 360 degrees. So your 9x will be 360 minus 9, okay, which is going to be 9x equal to 351. So your x will be 351 divided by 9. 3 into this 3 into this 1, into 5 is 1 again, and into 21 is 7. Then 3 again is 1, 3 again here is 3 times 3, 9, 10, 11 to 27. 3 times 9 is 27. We have that x equals to 39 degrees. Okay, so that's it for that one. And this one again, we have something similar to what we had before. Here we're told that we should find our angle A. Now this angle now is the same as saying exterior angle of this plus exterior angle of this. So we'll find out that the diagram is a regular hexagon and a regular octagon. So we'll have 360 over hexagon is 6 sides plus 360 over octagon is 8 sides. Okay, that's exterior angle of this plus exterior angle of this. So we'll have 60 plus 4 into this 2, 4 into this 90, 2 into this is 45. So 45, which is going to give us 5 105 degrees. Okay, it's just the same kind of format. If you know how to calculate the exterior angle and the interior angle, you don't have any issues with polygon. Now, this another question on polygons. We are told that the diagram shows part of a pattern made from tiles, and the pattern is made from two types of tiles, tile A and tile B, and then tile A and tile B are regular hexagons. So we're now told to find out the interior angle of tile A. Okay, now let's look at this closely. You're seeing tile A that has, a regular hexagon has equal sides and equal angles. Now we're seeing tile A that has this side equal, this side equal, this side equal. Okay, this side equal, all the sides are equal. Now same thing here. Now look at these triangles. You see that this is tile A, tile A, tile A, and tile A. Okay, now this side that forms tile B is the side of tile A, that's a regular hexagon. This side is the side of tile A, that's a regular hexagon, and this is the side of tile A, that's a regular hexagon. Okay, so all the sides are equal, so that means all the angles inside are also equal. So how many angles are there in a triangle? There are 180 and 180 degrees in a triangle. Okay, so dividing by 3, we'll have each side to be 60 degrees. Okay, so 60 degrees, equal angles of a triangle. Okay, now after getting 60 degrees, we've seen that here is 60 degrees. So that means this angle now is 60 degrees, this angle is 60 degrees, and this angle is 60 degrees. Now, looking at this hexagon now, we'll find out that this is an angle of the hexagon, and this is an angle of the hexagon. Okay, now we're now saying that, let's call this angle of hexagon X, and this angle of hexagon, or not really hexagon, I'm sorry, a polygon rather. This is an angle of a polygon, and this is an angle of a polygon. So let's call this angle of polygon X, and this angle of polygon X. Okay, we don't know the values. Okay, we don't know the degrees, but we also know that angles at a point is 360 degrees. Okay, so we're now going to call, and we call this X and call this X because we know it's the same polygon. Okay, and all the angles of a polygon are equal. Okay, so whatever we call this, we can also call it this one, is right. Now we're now going to add this, and this, and equate it to 360 degrees. So we have that, we have this as 60 degrees. We have 60 plus x equal to 360 degrees. Reason angles at a point equals 60 degrees. Now we have 2x plus 60 equals to 360 degrees. So 2x will be 360 degrees minus 60, which is 300 degrees. So our 2x will be 300 degrees, and our x will be 300 divided by 2, which is 150 degrees. Now what's our x now? Just an angle of the polygon. Well, but we are asked to find the number of sides of polygon, so we have to find our equation that equates each angle of a polygon to the number of sides. So using this, 180 into n minus 2 over n. Okay, we are going to, this is the formula for finding an angle of a polygon. Okay, now we're going to equate this equal to 150 degrees. Okay, now multiplying both sides by n, you're going to have 180 into n minus 2 equal to 150n. Okay, now multiplying this out, you have 180n minus 360 equal to 150n. Now we're going to subtract 150 from both sides. You have 180n minus 150n minus 360 equal to 150n minus 150n. Okay, now this is going to be 30n minus 360 equal to, this is 0. Now adding 360 to both sides, you have 30n equal to 360. So your n is going to be 360 divided by 30, which is going to be 12. So you see, from knowing the kind of formula to use, we're able to find the number of sides. So no matter how they twist it for you, you can still be able to look at it and find out the number of sides or the angles involved or things like that once you know the formula to use. So that's it for polygons and angle properties of polygons.